In this part of the module, we're going to be putting together everything we learned about perimeter in order to solve complex linear measure problems or complex perimeter problems. I'm only going to go over two big examples, really, but you can use the same approach that I'm going to use today to tackle any unique perimeter problem. The only thing you'll need to remember is that for any complex shape, make sure that you break it into simpler shapes first before you calculate its perimeter. And the second thing that you need to know is an understanding of perimeter formulas. Now, it's not enough to have these formulas memorized. You need to understand what each piece of each formula means. And if you need a review of these formulas, you can go back to the videos in parts 1, 2, and 3, and you can watch the videos where I show you how to derive these formulas and what each variable or letter means. So what I'd like you to do right now is in a few seconds, pause the video and do this review exercise where you'll have to match a situation with the formula that you would use in that given situation. Okay, go ahead. Okay, so now I'm going to go over the solutions to this review matching exercise. And I'm actually going to do this a bit backwards. I'm going to go over the formulas first, just to review what they are and what they mean with you. And then I'm going to do the matching. So the first formula here has the letter C, and we know that that stands for circumference. Circumference means we're working with a circle. So this formula will give us the circumference of a circle when the radius is known. So I know that because the variable r is included in the formula. That means we need to know what it is. The second formula here has the perimeter. So we're calculating the perimeter of a shape, and then it looks like we're adding 3 different numbers. That means we have 3 different sides, which means we're working with a triangle. Okay, so say triangle ABC. The next one shows 2L plus 2W. This is an L, by the way. So 2 lengths and 2 widths. That means I'm working with a 4-sided shape, which is a rectangle in this case. 2 lengths here and 2 widths here. The next one has a C, so that's circumference. So we know we're working with a circle. There's also that pi, so that's a really good indicator to tell us that we're working with a circle. And then there's a letter D. So this formula helps us find the circumference of a circle when the diameter is given, not the radius. The last one here is perimeter equals 4 times S. So 4 times that same number. So we have 4 groups of the same number. That means we're working with a square because a square has equal sides, 4 equal sides. So to find the perimeter of a square, I add the same number 4 times or just multiply it by 4. So now that I understand what these formulas mean, let's quickly do the matching because we basically did all the work. So the first one says, this formula is used to calculate the circumference of a circle when the diameter is known. So we know that that would be D. Next question reads, the formula is used to calculate the perimeter of a rectangle. We've determined that that is C. This formula is used to calculate the perimeter of a square. We've determined that that is E. This formula is used to calculate the circumference of a circle when the radius is known. So we've determined that that is A. And then the last one is, this formula is used to calculate the perimeter of a triangle, and we've determined that that is B. Now, if you've struggled with this activity, I highly recommend that you go back and watch the videos from parts 1, 2, and 3 before you proceed to the next 2 examples. All right, so now I'm going to start the first linear measures example. And this one involves the blueprint or the layout plans for the Popowich family's home. And what we're required to do here is to calculate the perimeter of the outside of this house. So we can see that there's multiple rooms in this house and they have some dimensions in there, but those don't matter. Perimeter only measures the distance on the outside of the shape, on the border of our shape. Now, this is not a shape that we're familiar with, but it doesn't really matter here because we know that to calculate perimeter, all we need to do is just add the distances around the shape here. Okay, so what I'm going to do is I'm going to outline the parts that I'm going to need to add to see if anything is missing. So I'm going to start at the top here. This is known, this is 12, this is known, this is 20, this is 15. I know what that is. I don't know what this measure is right now, but these two are known. This one is known, and this one is not known. They're not known right now, but we can figure them out. So let me highlight the ones that we will need to figure out. It would be this one right here and this one right here. Once I know what those numbers are, to calculate the perimeter, I'll just have to add all these numbers to find the perimeter. Okay, so let's start with, say, this one right here. I want to know what this distance is. Now, this is the width of this house, right? So theoretically, it should be the same width as the other side of the house. Now, there's nothing here in the house, but the distance from here to here should be the same as the distance from here to here. Okay, so I'm going to draw an imaginary line here going this way that will show that the distance from here to here is equal to the distance from here to here. So if I figure out what this distance is, it'll be the same as the distance here. Okay, now why am I focusing in on this side to help me? It's because there's some values that are known to us here. That's why I'm looking at that side. Okay, so the distance from here to here is 15, so this is known. Fantastic. Okay, that means the distance from here to here is also 15. Now I need to know the distance from here to here. Now what's going to clue us in on those numbers are these two measurements, because I can imagine that I'm taking this part of the house and I'm sliding it out like this and putting it here. That's not actually happening, but we're just visualizing so that we can get that measure. So that means this would be 5 feet, right? I can also visualize that I'm taking this part of the house and I'm just sliding it to the left, so this is 10. Right? And that's totally okay because all of these are vertical lines, right? So it's totally okay. Now, if this is 5 and this is 10, together they are 15. So this is 15. Okay? That means the total distance from here to here is 15 plus 15, which is 30 feet. Okay? So now I've calculated one missing value. You don't have to erase your work, but I will in this case because when I find the other missing measures, I don't want the screen to be too overwhelming. So I'm just going to erase these numbers because now I'm going to move on to the other missing value, this one right here. And I'm going to use the same approach that I used when I calculated this side. Okay? Now, this is a part of the length of the house. Okay? So this is the length of the house. It's going to be the same length from here to here as well. Okay, because all of these lines are horizontal, so they should add up to one another. Now, the length here is not known, but we can easily figure it out. We can figure it out by adding these numbers. So if you use your calculator, 20 plus 12 plus 18 should give you 50 feet. Okay, so the total from here to here is 50 feet. That means the total from here to here should also be 50 feet. Now I know that from this point to this point, the distance is 36. So the only thing missing is the distance from here to here. Okay? Now, if I look upwards, that's the same distance from here to here. So if I figure this out, I'll know what this equals. They are the same thing. Okay? Now, how can I figure it out? Well, if the total is 50, and I know that this is 36, I know that this number, once I figure it out, has to add up to 50 when I add it to 36, right? So to find the answer, I'm going to go 50, take away 36, and that should give me 14. So this measurement here is 14, which means this has to be 14. Okay? So I'm going to do that again down here. I'm going to zoom in. If this is 50, and from here to here it's 36. What's this measure? What's this mystery number? Well, I'm going to take the total, take away 36, and that will give me 14, which is the distance here. Okay? Okay, so I'm going to write that down, and I'm going to erase all my scribbles. This measurement here is 14 feet. So now I have all the missing pieces to calculate the perimeter of this house. So I'm going to show my work down here. Perimeter will equal, where should we start? Let's start here, and then I'm gonna go counterclockwise like this, okay? So 20 plus 15 plus 14 plus 5 plus 10 plus 36 plus 30 plus 18 plus 12, and that's everything. And when you add all these together, give me a moment, we get 160 feet. So that is the perimeter of the house. Okay? Okay. So now we're going to take this a step further, and we're going to change the layout of the house. This family decided to add an extra bedroom here, and now we are asked to find the perimeter of the house according to this revised plan. So we're going to use the same approach, except this time it should be easier because this is a shape that we're very much familiar with. This is a rectangle. Okay, so I'm actually going to use the formula for a rectangle, the perimeter of a rectangle, which is 2 times length times 2 times width. Okay, now let's determine what the length is. Let's determine what the length is. The length is here, okay, and it's, of course, it's equal to this length here. So we determined that this is 50, right? We added it earlier. It's 50 feet, so this has to be 50 feet, okay? We've determined as well that this is 15, and this 5 here can slide out, so this is 5, and this 10 can slide out, so this is 10. So together, this is 30, and this is 30 as well because it's a rectangle. So now let's use our formula. Our length is 50, our width is 30, okay? So perimeter equals 2 times 50 plus 2 times 30. And remember to use order of operations. So we do the multiplication first. 2 times 50 is 100, and 2 times 30 is 60. And then we add them together, and the result is 160 feet. Now, what's really interesting is that even though we changed some of the layout, we added an extra room to this house, the perimeter never changed. It's 160 feet in this case, and it was 160 feet before. And the reason for that is we didn't really add anything to the distance around the house. When the shape of the house was like this, okay, and then we added an extra room here, all we did was we slid this distance down below to here, and we moved this one here to the left. So we didn't really add any new distances. We just shuffle things around a little bit to create a perimeter that is rectangular. Okay, and of course that can work with any similar shape. Let me show you one that looks more like stairs. So if I had something like this, I can easily calculate the perimeter for that by converting it into a rectangle as well. I can shift these sides to the left and then pretend that they're here. See what I mean? And then I can shift these horizontal lines upwards. And see, this one is here, this one is here, and this one is here. And the perimeter of the rectangle would equal the perimeter of the stairs, because we didn't really add any distances, we just moved them around. Okay, so that concludes our first example. In the next video, we will tackle another example that has circles.